Good morning. This is our presentation for filters and its characteristics and filter design techniques. So, what is a filter? A filter is a circuit designed to process a signal by allowing certain frequencies to pass while attenuating or blocking others. Filters are characterized by their frequency response, which determines how they affect different frequency components of the input signal. So basically, if you have a low pass filter, it will attenuate frequencies higher than the cutoff frequency and only lets the frequency below the cutoff frequency to pass. So filters are essential tools for ensuring reliable, efficient, and high quality signal transmission and receptions. And they play a vital role in shaping and managing signals. So, what is frequency response? Frequency response of the systems this is of a system describes how the system responds to input signals at various frequencies. It provides insight into the amplitude and phase characteristics of the system across a range of frequencies. And it has uh, these characteristics, which is the amplitude response, phase response, and transfer function. Amplitude response shows how the amplitude of the output varies with frequency. So the phase response indicates the phase shift introduced by the system for each frequency, and the transfer function for a linear time invariant or LTI system. The frequency response is the Fourier transformation of its impulse response, or evaluated as h of f is equal to y of f over x of f. So moving on to filters. Uh, A low-pass filter, as I said before, is a system that allows signals with frequency below a specific cutoff frequency to pass while attenuating frequencies above the threshold. It is one of the most common and fundamental types of filters in signal processing and other fields. So basically, it allows signal with lower frequencies to pass through while attenuating signals with higher frequency. And it can be denoted as 1 over 2 pi RC, wherein the R is the resistance and the C is the frequency. So one of the real world applications of low pass filters are like for the audio processing. It can remove high frequency noise or unwanted components from audio signal, and can filter out high frequency noise from transmitted signals. And for like radar and navigation systems, it can filter out high frequency components for clearer signal detection. So moving on to high pass filters. A high pass filter is a system or circuit that allows signals with frequencies above a specific cutoff frequency to pass while attenuating signals below this frequency. So just like a low pass filter, it attenuates a range of frequency above that or below the cutoff frequency. In the case of high pass filters, it attenuates low frequency signals, and can also be denoted still as 1 over 2 pi RC. And for its real world applications, it can, for audio processing, it can eliminate um, hums and rumbles from audio signals. It can boost high frequency components and improve clarity in music or recordings. It removes for communication. It removes low frequency components of or DC bias from modulated signals, and eliminates low frequency interference caused by nearby electrical equipments, and removes low frequency sounds like wind noise or and such from speech recordings.
So for the bandpass filter, a bandpass filter is a system or circuit that allows frequency within a certain range, or called the passband, to pass through while attenuating frequency both below and above this range. It is denoted with the formula bandwidth BW is equals to F2 minus F1. For the bandstop filter, bandstop filter is also called a notch filter or band reject filter. It is a system or circuit that attenuates signals within a specific frequency range, and while allowing signal outside this range to pass through with minimal attenuation. Next is for the application. So the application is that it will use in the control system to have a stability and performance analysis. For the industrial robotics, it's a robotic arm use feedback control to achieve precise motion and positioning. Stability analysis ensure that oscillations in joint movement are minimalized. For the aircraft autopilot system, it is a frequency response analysis ensure the system reacts smoothly to turbulence or pilot's input, maintaining stable during flight. For the signal processing filter, it is also a filter design that signal processing heavily relies on frequency response to design filter for enhancing or suppressing specific component of a signal. And for the audio equalization, it is used for the music production and live sound reinforcement to balance frequency and improve clarity. For instance, a low pass filter might reduce high frequency hiss and telecommunication, and this filter remove echoes from calls to improve audio quality. And for the image processing application, it is also a use for a low pass filter, reducing the noise in medical imaging like MRI, CT scan, and right now it is also used for the AI to enhance a noise image to a clearer version of itself. Next is for the communications. It is also used with wireless communication using bandwidth optimization. So, yeah. And wireless communication is used as cellular networks use filter to ensure different frequency like LTE, 5G, and making sure that it is not overlapping to other frequency. And for the satellite communication, it is filtered used to isolate signals from a specific channel or transpondent, allowing multiple signal to share the same frequency band. And for the modem and routers, bandwidth optimization through filtering improves data rates by eliminating noise and ensuring signal remain within specified frequency limits. And also for the audio and video broadcasting, it is also used with the frequency response to minimize cross channel, and it is also broadcast to a specified frequency. And for the fiber optic communication, it is a optical filter separating different wavelengths of light and allowing multiple data streams to travel through a single fiber. So for the filter design techniques, filters are used to allow or suppress a specific frequency component of a signal. Filter design involves creating a filter that meets specific performance or criteria. For the design techniques, analog design, uh, first is the bezel filter, which preserves the waveform of the signal. As you can see under the picture, it is also a minimal phase distortion. Yeah. And the second is the Butterworth filter. It's a maximally flat amplitude response in a pass band, as you can see on the picture. And then number three is the Chebyshev filter. It's also a steeper roll off than a Butterworth, but with ripples in a pass band type 1 or stop band type 2. Yeah. And for the 4, it's an elliptic filter, steepest roll off with a ripple in both pass band and stop band. That's all for the presentation, and thank you.